your chart is on your unit circle. Exactly, they're together. So, but, okay, lesson 5.3. We are learning, yes, more identities. Specifically, it's just one more set that we're adding today. And these are called your sum or difference identities. Okay, we have sine of a sum or difference, cosine of a sum or difference, and tangent of a sum or difference. So today it's all about how do we use these. Okay, we'll have to apply them in later lessons still. So today is just learning how to use them. As you look at sine of a sum or difference, notice it's sine of x plus or minus y. And then it's equal to sine of x cosine y plus or minus cosine x sine y. And so the idea here is that if it's plus or minus, if you have a plus sign here, you're going to use a plus sign here. If you have a minus sign here, you're going to use a minus sign here. But the idea of these sum or difference identities, I mean, if I skip and just look at example 1. Example 1 wants what is the exact value of cosine of 15 degrees without touching your calculator. Is 15 degrees on our chart? No, that's not one that's on our chart, is it? We have 30, 45, and 60. And so the idea is that these identities help us to find something like 15 degrees. Okay? So when you get to cosine of two numbers added or subtracted. Now notice the difference here, it's plus or minus y. Over here, it's minus plus. And what that's saying is that when you have a plus here in the original problem, we're going to use a minus. When it's a minus here, we're going to use a plus. Okay, and I'm not talking about these too much because really we just need to jump into them to use them, and I'll explain it as we go. We also have tangent. Tangent is a fraction. Notice it's tangent of x plus or minus y. Well, it's on top, it's tangent of x plus or minus tangent of y. So in that case, you use the same sign. In the denominator, it's 1 minus plus tan x tan y. And so on the denominator, you use the opposite sign. So that's just kind of their way of showing which sign you use. Now, I'm going to jump right into example 1 because I can explain these all day, but until we use them, they're not going to really make sense. So example 1, and this is what you're going to see in the first handful of problems in homework. I think this is the first 10 is what you're doing this type of problem on. And it says find the exact value of cosine of 15 degrees without using a calculator. So exact value means I don't want a decimal. If you put a decimal on your paper, I'll know you picked up your calculator. Okay. Exact value means we're talking radicals, fractions, that type of thing. Now, 15 is not on my chart, is it? What numbers are on my chart that could make 15? Okay, how do 30 and 45 help me? Okay, 45 degrees minus 30 degrees is 15 degrees, correct? Okay, and that's how we can do this. So I'm going to rewrite. If they want us to find cosine of 15, we're going to do this as cosine of 45 degrees minus 30 degrees. So is that true? Is that still cosine of 15 degrees? Yes. And so the idea then is that this 45 degrees and this 30 degrees are my x and y in my equation up above. So every time I see x, I'm going to call it 40. I'm going to put in 45 degrees. Every time I see y, I'm going to put in a 30 degrees. So if we look at cosine, okay, what is our cosine formula? Cosine of x minus y is going to be, notice it's cosine, cosine, right? So cosine x, cosine y, which means I'm going to write cosine of 45 degrees times cosine of 30 degrees. What sign do I use? Okay, because this is the cosine, it was plus minus here, it's minus plus here. So that's saying we're going to use the opposite sign. So since I had 45 minus 30, this is going to be a plus sign here.
So there can be like plus and plus, or Minus and
not on the cosine. On the sine, it would have been plus and plus or minus minus. It would have been the same.
Okay.
On the cosine identity, we use the opposite. Okay, and we'll practice that more as we go. So it's cosine x, cosine y. We're doing plus, and then it's sine x, sine y. So that's going to be sine of 45 degrees, sine of 30 degrees. Okay. What do you know about the cosine of 45 degrees?
Pi over 4. Or you said the.
Square root of 2 over 2.
Yeah.
Cosine of 45 degrees, according to my chart, is square root of 2 over 2. And I'm going to use the rationalized version because it's going to, we're going to want a rationalized answer here in a moment. What's the cosine of 30? Square root of 3 over 2. And these are straight off of our chart, right? If you have your unit circle and you're using your unit circle, you can find them on your unit circle as well. Okay, what is the sine of 45 degrees? Square root of 2 over 2. Times, what's the sine of 30 degrees? 1/2. Again, we're not picking up a calculator because it wants an exact value. So, square root of 2 over 2 times square root of 3 over 2 is what? Square root of 2 times square root of 3 is square root of 6. 2 times 2 is 4. Plus square root of 2 over 2 times 1/2.
Square root of 2.
Square root of 2 over 4. Usually the answers are written as one fraction. So what is square root of 6 over 4 plus square root of 2 over 4? No? Yeah. Square root of 6 and square root of 2 are not like radicals. So we're going to write it as square root of 6 plus square root of 2 all over 4. That is your answer.
Wait, this doesn't. I kind of like this.
Yeah, me too. It's way easier than the last thing.
I would.
I would say,
I would.
I mean, there's hard pieces and easy pieces of this, okay? I'm not, but it is definitely a change. And I think that's what, I know that's what some of you need, is a change. And you've got your change here, okay? Now,
I appreciate the change.
it said without using a calculator. I'm using my calculator just to show you a check option. On my calculator, cosine of 15 degrees. Notice I put my calculator in degree mode. And if I do cosine of 15 degrees, my answer is that lovely decimal. Now, how do I check myself?
Well, you do square root of 6 plus square root of 2 and then divide it by 4.
Square root of 6 plus square root of 2
That should equal to a point.
divide by 4. And guess what? They're identical. Okay? So that's kind of a check for yourself. Not that it really helps a whole lot, other than you get to the end and you know it's right. But, it is equivalent. But the difference was I wasn't supposed to pick up my calculator to do this problem. Okay? So obviously anyone that puts that 0.9659 answer, I know you didn't use, Besides the fact, do I expect to see some work shown here? There's work to show, isn't there? You can't do this without showing work. Okay, so that is one type of problem that you're going to see. And depending on how time goes at the end, I may try, I'll be honest, the tricky type of those are going to have to be when we have to throw in radians. And so if I get a moment at the end of class, I'll talk about radians a little bit, because that's the hard part of those. Okay?
I'm not going to be here tomorrow. Am I going to miss something really important?
Always. Tomorrow this homework will be due tomorrow because we'll get through the notes today. So tomorrow there will be questions over this lesson, and then possibly begin the next set of notes. Depends on how the day goes and how questions go. And I don't remember. I don't look that far ahead. I'm day by day here. I just know that hopefully we'll start notes tomorrow, but we wouldn't get through them tomorrow. Because I know I usually have to allow some time for homework questions on this section. Okay, example 2. If you liked example 1, which example 1 had some work behind it, yes? Wasn't horrible though. You're going to love example 2 type problems. It says, write each of the following expressions as the sine or cosine of an angle. So I want to know the sine of 22 degrees times the cosine of 13 degrees plus the cosine of 22 degrees times the sine of 13 degrees is equal to either the sine of what angle or the cosine of what angle. So what do you notice about this right here? What form is it in? So if I go back up here to the top, can I get it all on the same screen? Barely. This is a sine, cosine, cosine, sine. Which identity uses sine, cosine, cosine, sine? This is sine. So I know that my answer is going to be the sine of some angle. Because it's sine, cosine, cosine, sine, sine, cosine, cosine, sine. Now, what are my x and y values? 22 and 13, right? Because it's sine x, cosine y. Cosine x, sine y. So that means I am looking at using 22 degrees and 13 degrees as my x and y. And then one last important question.
Plus, because it's sine.
Levi says plus because it's sine. Do you agree?
Yeah.
Plus, because it's plus.
Okay, this is the sine identity. And up here it was plus minus, plus minus. So that means you're using the same plus or minus sign. And so in this case, since it was plus, this is plus. Don't pick up your calculator, but rewrite. What is sine of 22 plus 13?
35.
Sine of 35 degrees. No calculators. I don't want to know what the sine of 35 degrees is. I want to know sine of 35 degrees. Okay?
Only for it to get harder.
I'm being honest with you. There are some hard parts in homework, but it comes from the 1 through 10 type problems, which were like example 1. So that's why I said, if I get a chance, I'll go back and try and do another example like that. Okay? Are you okay with this, though? No tricks there.
Wait, that's the answer?
That's the answer. I'm done. I'm ready to move on to example B.
No, I like that.
I hope so.
It'd be cool.
Okay. Example B. We're going to throw in radians, but you can do this. Radians just mean I'm throwing in fractions at you. But we can do this. No. I want a radian answer. They give me radians, I want radians. They give me degrees, I want degrees. But they give me radians, I want radians back. Okay, so first of all, cosine, cosine, sine, sine. Which form does that fit up above?
Cosine.
That's the cosine form.
It's going to be
What are my x and y values?
pi over 3 and pi over 4.
You guys okay with that? It's xy, xy. So this time it's going to be cosine of pi over 3
Minus cosine of pi.
and pi over 4. There's a plus sign here.
Yeah, but it's cosine is opposite.
But we're going to use opposite because if you go back up, in the cosine it's plus minus here and minus plus here. So you use the opposite sign of what is provided. Since plus is provided here, we're using minus. Now, you don't get to stop here. I want to know what is pi over 3 minus pi over 4. So my question to you becomes, how do I subtract fractions? Common denominator. So this is not trig. This is middle school, maybe even elementary. What is the common denominator between 3 and 4? 12. So I'm going to think of these as 12ths. And the pi, don't worry about the pi. We're just going to plop it in there. But think of this as 1/3. 3 times what is 12? 4. So 4 times pi is 4 pi. 4 times what is 12? 3. So 3 times pi is 3 pi. Sorry, it got hard for a moment and forced you to do fractions. So what is 4 pi over 12 minus 3 pi over 12? 1 pi over 12